also. Clear?
Hello everyone, today we will be solving problems from thermodynamics, and let me confine to a problem based on basics of thermodynamics. So the question goes on this way. A football was inflated to a gauge pressure of 1 bar when the ambient temperature was 15 degrees Celsius. When the game started the next day, the air temperature at the stadium was 5 degrees Celsius. Assume that the volume of the football remains constant at 2500 centimeter cube. Gauge pressure of air to which the ball must have been originally inflated so that it would be equal to 1 bar gauge at the stadium is. Now let's look at the question again, breaking it into parts. A football was inflated to a gauge pressure. Now here it is very clear that there is a football stadium in which there is a football, and on day 1 and day 2 he is talking, so suppose tomorrow and today. So today the gauge pressure, that means he is using a pressure gauge to check the pressure of the air that is filled in the football. So here if you see, the gauge pressure is 1 bar he is saying. So before going into that, what is gauge pressure? It is not the actual pressure of the air which it shows. The pressure that is shown by the gauge is not the actual pressure. It is a reference value. It is not the absolute value. Then how do we get the absolute value? It gives the pressure, the gauge pressure gives the pressure with respect to the atmospheric pressure. So the absolute value of the air that is filled within the football is actually atmospheric pressure plus gauge pressure. So that means on day 1, that is today, when the temperature is 15 degrees Celsius, the football which is there in the ground has shown a gauge pressure of 1 bar, which means its actual, that is absolute pressure, is atmospheric pressure plus gauge pressure, which is 1 bar plus 1 bar, that is 2 bars. So the absolute pressure of the air filled in the football on day 1 is 2 bar. The gauge pressure is 1 bar and the absolute pressure is 2 bar. Now the same thing is here. If we continue, when the game started the next day, the air temperature at the stadium was 5 degrees. So tomorrow, say we are going to start the game, and obviously when we see that the temperature, ambient temperature has got reduced by 10 degrees Celsius, then we can expect it's a very practical case. When there is a reduction in temperature, the vibrations of the molecules get reduced and thus the pressure falls down. It is generally a misconception that people think that certain amount of air has left the ball or escaped from the football, but no. And that is what is the magic of this problem here. So he says on day 2 the temperature, atmospheric temperature is 5 degrees Celsius. So for that particular 5 degrees Celsius, he is saying assume. He has used a word assume. Yes. If you see here, the ball got shrinked. The volume of the molecules inside the ball is not the same again. The volume will obviously change because the temperature has changed. Because the temperature has changed, the vibrations will reduce and hence the molecular cohesions will reduce, and hence the pressure exerted by the gas or air that is filled inside also will reduce. So pressure is going to change and also volume is going to change. But he says, he asks us to assume that the volume of the ball remains constant, and he gave one particular value. Yes, this is an assumption. So now on day 2, for a reduced ambient temperature of 5 degrees Celsius, what is the reduced pressure he is saying? Simple. So the question here is, on day 1 at temperature 15 degrees, the pressure is so and so, the gauge pressure. The corresponding absolute pressure is 2 bar. On day 2, for the temperature of 5 degrees Celsius, what is the gauge pressure? What is the absolute pressure is what asked. And then he asks us one more important thing, that is gauge pressure of air to which the ball must have been originally inflated so that it would be equal to 1 bar gauge. That means on day 2 if I check the gauge pressure, on day 2 if I check the pressure of the molecules inside this ball using a big pressure gauge, the pressure should be 1 bar. If it has to be 1 bar, what should be the gauge pressure recorded on day 1? That is the question asked. Very simple. On day 1, pressure is 1 bar, means we'll get some pressure on day 2, a reduced pressure. Now the question is, if suppose I want to see the pressure gauge to read a 1 bar pressure, then to what pressure should it be inflated on day 1? That is the question. So now let's look into the solution. So on day 1, the temperature of the atmosphere is 15 degrees Celsius. The gauge pressure recorded is 1 bar. So the absolute pressure is 2 bars, which is atmospheric pressure plus gauge pressure. And here we are assuming air as an ideal gas, and we are applying the ideal gas equation. P1V is equal to mRT1, where the general notations have the general meaning, that is pressure, volume, mass, characteristic gas constant and temperature. So here we have T1, that is the ambient temperature on day 1, P1, that is the pressure recorded by the gauge plus atmospheric pressure, that means the actual absolute pressure exerted by the molecules of the air inside the football, that is P1. We also have V1, they have given one value, that is 2500 centimeter cube. R is a characteristic gas constant, so it is 287 kilojoule per kg Kelvin for air, and mass is what we have to find. So M is equal to P1V by RT1. I have converted the pressure which is 2 bar into Newton per mm square, as 1 bar is 10 power 5 Newton per meter square. So 2 into 10 power 5 Newton per meter square into the volume in centimeter cube. I have converted here it into meter cube by R, the characteristic gas constant, that is 287 kilojoule per kg Kelvin, and the temperature in kelvins, that is 273 plus 15. Then the mass of the air that is filled in the ball turns out to be 6.04 into 10 power minus 3 kg. Yes. Now here the point is, as I have told, he is asking us to assume that the volume is constant, means there is no change in the volume of the ball or volume of the molecules, volume occupied by the molecules within the ball. That means no air molecules are escaping from the ball. That means we can say that the mass is conserved on day 2. Also the mass will remain same. So it is still the air which is an ideal gas as per our assumption. So still we can apply the same ideal gas equation with the new pressure at new temperature 5 degrees, that is P2V is equal to mRT2. P2 is the absolute pressure of the molecules, pressure exerted by the molecules within the football. V is the same volume, because he says that the volume remains constant. M is the mass, the same mass, because it is conserved, as we have discussed that no mass escapes, no air escapes from the football. And R is a characteristic gas constant for the same air, and T2 is the new temperature, atmospheric temperature, which is 5 degrees Celsius. So applying this law, we can find out P2, the absolute pressure on day 2, and that turns out to be 1.92 bar. Be careful, the absolute pressure on day 1 is 2 bar, the absolute pressure on day 2 is 1.92 bar. Now he is talking about the 1 bar gauge pressure. That means we are worried about gauge pressure, not the absolute pressure, the pressure that is recorded by the gauge. So now if we have to find out the gauge pressure on day 2, then it is obviously absolute pressure is equal to atmospheric pressure plus gauge pressure on day 2, which turns out to be 0.92 bar. Automatically 1.92 minus 1 gives you 0.92 bar. So now I repeat, the absolute pressure on day 1 is 2 bar and the corresponding gauge pressure is 1 bar. The absolute pressure on day 2 is 1.92 bar and the corresponding gauge pressure is 0.92 bar. That means if today the gauge pressure is 1 bar, tomorrow the gauge pressure recorded is 0.92 bar. That means the decrement is 0.08 bar. The pressure got reduced from 1 bar to 0.92 bar. That means it has got reduced by 0.08 bars. Now the asked question is, if suppose on day 2 the pressure gauge has to read 1 bar, to which pressure should the ball be filled on day 1? That is the question. Obviously, when it has to show 1 bar on day 2, then it should be 1 bar plus 0.08 bar, that is 1.08 bar. So on the gauge pressure that has to be recorded on day 1, If it is 1.08 bar, then on day 2 the gauge pressure recorded will be 1 bar. So the answer here is 1.08 bar. Hello.